Hey guys, this is batch 11 and 12. Woohoo! So I'm going to use my notes that I got from class, right? And I'm going to do my best, right? It says growth hormones are often used to increase the weight gain of chickens. So we've all seen that in the store. It's like, oh, there were no growth hormones used in this chicken, or there were growth hormones used. Some people don't like that they're used, but unless it says they're not used, you can assume that growth hormones are used in chickens to increase their size, to make sure that they gain weight and they're as big as possible before they are killed and eaten. So in this experiment, we used 15 chickens. 3 were randomly assigned each to 15 different doses of growth hormone. So each were given a different growth hormone. So it's kind of like each chicken, instead of each chicken like each student was in a seat, each chicken was given a different level of growth hormone, so we could see it does more growth hormone lead to weighing more. Okay, so the subsequent weight gain was recorded for each of the chickens. So there is a chronological order here. Chronological order. We notice first the chicken is given the growth hormone, a dose of growth hormone, and then we measure their weight gain. So it makes sense that this should be our X value and this should be our Y value. So if it was graphed, we would think that if we were given no growth hormone, 0.2, 0.4, 0.8, 0.1, does it go up over time, right? Would we get dots that would show a positive linear association? That's what we're being asked. So question number 1, what is the equation of the least squared regression line? Okay, so we know how to do that. We learned how to do that. This is A and this is B. So the general formula is A plus BX. And this is A and that's B and this is X. So we're predicting the weight. So the little hat means weight gain, right? Predicted weight gain. And A is 4.5459. And this is our slope, 4.8323. And X is the dose. What was the dose of the growth hormone? So this is the dose of growth hormone. And in the Y, this would be our weight gain. Okay. So, and I know that it's positive because I noticed that my slope is positive. All right, so this part I'm going to skip. We'll do that in class, right? So then this is getting into our badge. We said badge 11 is a linear regression t-test. So that's this one right here, badge 11. And then it says do a confidence interval, so that's badge 12. Okay. So does this provide convincing evidence of a linear relationship? So starting out here, we can say state we must assume beta is 0. And we're thinking that the slope would be something other than 0. And even though we're giving it to increase weight, we see it's positive. But there's nothing in what we read that said, like our last problem, do the students in the front rows learn better? There's nothing, it didn't say, are the chickens given growth hormones fatter? Ooh, or is it? It says increase. Okay, so I think since it says growth hormones are often used to increase weight gain, so I think because of that statement, I would think this. So actually the answer key says not equal to, but I'm going to pick this. Okay. I think that's a better answer. Now I use the letter beta and I have to explain what it means. Ooh, hold on. There's a more precise eraser. Apparently that's important. Okay, beta is my true slope, right, of the least squared regression line of x on y. So of dose of growth hormone versus weight gain. Okay. Now, state, ready for our plan, right? Now, I don't have a lot of stuff here. I don't have a, I can say at least what we're going to do. We will perform a t-test for beta. And, oh wait, there's something special here. Yeah, it says assume that the conditions have been met. So we're going to say, we're supposed to assume that the scatter plot, so it's like maybe they already looked at it, right? The scatter plot shows fairly linear pattern, and the residual plot, no leftover patterns. We have independence because our population of chickens is greater than, we said 150. And our dot plot, they didn't give us, but we're supposed to assume that some other scientist must have looked at the dot plot of the residuals. And that dot plot must have shown no strong outliers, no strong skew or outliers. E. This stands for equal standard deviation. So again, we're supposed to assume that some other scientist looked at the residual plot and that plot shows similar variability for each x. And again, in real life, if we took the test and it said just assume that, we don't have to perform these, but we're practicing it because we need to learn it for our multiple choice for sure. And then we could say the chickens were randomly assigned to the 5 different doses. Okay, state plan. Now let's do our do. All right, so our general formula, z equals a minus b over s, and that is t. And so the actual is your little b, and your predicted is your beta over s sub b sub b. And this comes out of our problem. Okay, so what was b? That was this, right? What is this other b? That is 0, right? We said that we have to assume it's 0. Okay. And then the last one, what is this thing? That's this, see this SE of B. So it's next to that. All right, we're ready. We have B, 4.8323 minus 0 over 1.0164. And we get T must be 4.75. So we can look in the table and we get, what is our degree of freedom? It is n minus 2 because we have two variables. So 15 minus 2 is 13. All right. So using our table, we get a p-value of 1, 2, 3, 4. And I don't have to go to a table because they did it for me. So this is actually easier than some badges because I don't have to do anything in the calculator. They have already printed out the printout for me. Okay, that's my p-value. Beautiful. That's my p-value for my inference for slope. I'm doing an inference for slope. Okay. Oh, and that's appointment. I like the word, I'm doing an inference for slope. B is slope. State plan due. Ready to conclude. Because our p-value is less than 0.05, we reject the null. We do have sufficient evidence that A correlation between X and Y, dose and of growth hormone and weight gain in chickens. For chickens like these that were used in the study, right? And we also noticed that it is positive, right? So that there's a positive correlation. That's what we found. All right, now could we also construct a 95% confidence interval? And the answer is you betcha. Okay, so let's give that a shot. State plant do conclude. Okay, so we did that. State plant do conclude. So now we will perform. Okay, so state. Now I'm doing badge 12. And it seems to be a little bit easier. I can just talk about this beta, right? So the true, I kind of did this above, the slope of the least square regression line of dose of growth hormone versus weight gain in chicken. So I guess I kind of went off script. I probably should have, so please, I apologize. This is not wrong, but I probably should have said there's no correlation between growth hormone and weight gain. So that I can say there is a correlation between growth hormone and weight gain. Okay, that's probably a little bit better. Not wrong, but a little bit better. Okay, the true slope of that. Okay, so we have our state, and we have to say at a, what does it say? 95% level. So let's do it. State plan. So we will perform A. I love it. T interval for beta. What is beta? That's our slope, our least square regression line of our slope. All right, state plan do. Everything else, see above, right? We were supposed to assume it, and if you want to see us write it all out, we did. State plan do, general formula. Specific formula. Okay. And do we have these values? Sure we do. We already have B, right? We already have B. It's this number right there. We already have sub B. Where's that color? All right, so it's right there, right? This one, which is this number, and I got to put that number there. So I use the same numbers. So that's why it's like, oh, this is pretty much the same thing. Very interesting, right? So we get B is 4.8323 plus or minus T star. We have to get from this table. S to B, 1.0164. So we go to our table and we get, I don't have this number, but again, my degree of freedom was 15 minus 2 because I had 15 chickens. That's 13 chickens. All right, so let's do this. AP stats, formula sheet, there it is. All right, here's our formula sheet. Here's our T star. We see it's this T star. When I look at a degree of freedom of 13, and I float up from 95, so that's my sixth column over, 95 and 13, I get 2.160. There it is, 2.160, 2.160. Okay. Got that from the table. And the book gets, so when I add this and subtract this, I get 2.64, 7.03. Let's crunch those numbers over here really quickly. 2.160 times 1.0164. So 4.83 minus 2.195 and 4.83 plus 2.195. Yep, got that number. Yep, got that number. All right. So that's looking good. And I think we're done. Almost done. Let's conclude. We are 95% confident that the interval from blank to blank captures the true slope of the true least squared regression line relating y to x, weight gain, and dose of growth hormone. So let's put in these numbers. We got this number, 2.64, this number, 7.03. So what does that mean? Well, it looks like they're all positive, right? So it does look like we came up with a number and we can say we have sufficient evidence to say that there is a correlation here. And in fact, we have even more information. We have that we're not exactly what it is. We think that it's somewhere close to 4.8, but it could be anywhere from 2.6 to 7.3. So notice that, we'll do this in another class, but notice that some of this, interpreting this slope, might be even more important for the scientist that's studying these chickens. The slope would mean the change in y over 1. So if I was to interpret this slope, I'm essentially saying that we believe that the chicken would have 4.8 ounces of weight gain for every dose, one dose given. And so this would help us predict how much growth hormone to give it if we wanted it to hit a certain amount of weight gain. Thanks for joining me, guys. See you next time.